his computer and software and all kind of things. Let me see if there are people waiting to enter. No. Okay. And here is the teaching site, teaching.complexword.net, where you can find all the information that you may need. Maria Cristina Di Domenico, if you try to enter, I should see the request, but I don't see anything here. People trying to enter. Maybe she was able to enter, but I don't know. I enter, okay, with wrong email. I don't care about the email of people here. I don't want. Don't worry. For me, it's the same. You just have to sign to the form, and I put also here the link to the other course. Okay, let's start with NetLogo. I would like to know how many of you have already seen at least a bit NetLogo, or have you installed the NetLogo on your computers? If you have not done, I suggest you to install NetLogo, which can be downloaded freely. It is an open software, so it should run on all platform. So you can go to this site here. I put into the chat, and you can download the software. So I use a lot NetLogo for teaching essentially, and also for testing new ideas before passing to some more sophisticated language. It can be, I don't know, Python, MATLAB, C, Fortran, whichever language you want, because it is always a good idea to develop a model at least in two completely different languages, possibly on two different machines with different architectures, operating system, and so on. Okay, what is NetLogo? NetLogo appears like this for the simplest version, because it has also a three-dimensional version where you can develop systems in 3D, and also several extensions. Okay, let's start with, say, some model library. There are a lot of models already furnished with the platform that you can use as a starting point, or, for instance, as an inspiration. One of the things that I most appreciate is this one. Then we shall develop something from scratch. So this is a model of how self-organization can work. So let me first show you at a different resolution. Okay, first of all, let me illustrate what is this platform. This platform consists of an interface and a language in which you can develop things. The interface is composed by buttons like this that you can press for doing some action. Generally, there are at least two buttons, one for setting up everything and one for starting the simulation. Then you can have sliders in order to change some variable in an easy way, like this. And for instance, this changes the number of white things that you see here. If I put this, then I shall explain. Here you don't see only one, you see only one termite, and here you create about 1,700 termites. Okay, while this is the density of these yellow dots. Then I shall explain, but this is just for having an idea of what you can do. You can also put a lot of other things. So you see, there is not really a distinction between editing the interface and then using the interface. You can clearly just use the interface, or you can edit the interfaces, for instance, moving things and so on. Then there is normally an info tab where you have informations about the model that you are presenting, and then there is the code part that we shall explore in these lessons. You see that normal you can have a lot of funny effects without writing, say, pages and pages of code. So all this is essentially coded in these few lines. So what is this model about? This is a model in which, this is the world, so where everything runs. You can change, this is for, you can consider it as a sheet of paper divided into squares. Here in this case, there are 100 by 100 squares, but we can reduce the number. Everything can be edited. Then you can, here you are just increasing the size of these squares. Okay, Lorenzo. Okay, so clearly I have to reduce everything. So for instance, here you see, in this case, I have reduced the size of my world to 10 to 10 squares. I have asked 29% of them to become yellow, essentially. And then I have one termite. Okay, so let's study what does it mean. My world is composed, in this case, by 100 small automata. I can inspect. They are called the patch because they are patches of ground, essentially. Each patch, in this case, this patch here, yeah, I can choose another in the middle, for instance, this one. So now I'm watching this patch, and this is the neighborhood of this patch here. For instance, it has every patch has coordinates. This has coordinates 5 and 1. Maybe I can increase. No, I don't. I cannot increase the size of this. But I hope you can see. Let me know if there are problems you can see and so on. Okay, so each patch is fixed in position. It executes commands that I send to them. They can access the state of variables of other patches. And for instance, they have, say, by default, coordinates which are not mutable. So I cannot move a patch from one side to another. They have color. I can change this. And if I change color, there is a color table so that it changes color. It can have a label. So I can make things appear attached to some patch. It can be useful for debugging, for instance. And clearly, also the label can have its own color. And so on. Okay, so these are patches. And then we shall develop from scratch a model with this, for instance. And above the patches, there can be moving agents that are called the turtle. So, for instance, this is my turtle. I have just one of them. And clearly, turtle have a lot of other coordinates. For instance, they have a serial number in order to be identified. So the first turtle I create is turtle number 0, then number 1, number 2, and so on. They have a color, as so I can change the color of the turtle. Or this is okay. Normally I don't edit this. These are only for debugging and for showing. Normally they are changed by the program or according to what they do. They have positions, and if I change positions, I move the turtle. Clearly, also this generally they move according to some scheme. They have a shape. This is clearly shape bug, but I can change shape if it makes any sense, color, etc., etc. Okay, and then we shall see how they behave. So these are a button. You see that this is if you a button can also be edited. A button corresponds to a procedure in the code page, in the code tab. So here I have the procedure for activated by this button. And I can make things slower in order to see what happens. And so, for instance, in this model, I have this turtle, this bug, who moves more or less at random. When it is white and it meets with a certain probability a patch, a yellow patch, it picks the patch. The meaning is that these yellow patches are pieces of wood. So they are scattered around. And in this simple model, the idea is that a turtle which is white, which is not carrying any piece of wood, if it meets a piece of wood, so it goes over a piece of wood, with a certain probability it picks it up and it becomes orange in order that I can see. Then if with a certain probability, if it is carrying a piece of wood and it is moving from a piece of wood to an empty square, it may leave there the piece of wood. So the idea is very simple. No? You have agents that moves randomly. If they meet a piece of wood with a certain probability, they take it. Then if they step off a piece of wood into an empty site, they may leave it there. So this is the very simple rules. Now let's see what happens in a large situation. I have to reduce the patch size here, maybe also a bit smaller. I put the slide at the maximum speed. Maybe I can put more turtles. Then when I let them go on, the funny thing that happens is that only due to these very simple rules, they form clusters of wood. These clusters takes essentially a round shape. It is very similar to what happens with water droplets in air. No? The droplets may leave, may have some water molecules that are going off or others that stick to the surface, and there is an effective surface tension that makes these things essentially circular. And then if I wait, or if I let the system evolve faster, you see that the smallest the droplets evaporates essentially because they have a lower surface to volume ratio. Now you see this one is evaporating. There is no nucleation, so no new patches, new droplets can appear. And at the end, all pieces of wood will go into just a large random circular pile of wood. So essentially, this is an example that illustrates that several mechanisms that, for instance, govern the aggregation of water droplets or even asteroids, or the building of nests of insects and so on, can be, say, modeled using several rules, but they give essentially the same results. Here there is a conservation of the number of yellow dots. There is an effective surface tension and an effective vapor tension that makes smaller droplets to evaporate. And so there are a lot of very interesting features from the point of view, say, of theoretical physics, clearly. But the model is completely different from what, say, a physicist would have done for, say, droplets of water. This was born in order to explain how can insect self-organize without an external direction, just based on microscopic rules. Okay, so and now I shall start developing a model from scratch, but I invite all of you to think of simple models, propose them in the chat or sending me an email and so on, so that I can okay, now I was wondering if I was recording. I hope yes. And so that we can try to develop your own model in the next meetings. Okay. Okay. So let's start from scratch, and let's start from say, no, I don't want to save it. New discard. You can, I suggest you, if you can, to follow what I'm doing so that you can practice directly with the model. I'm trying to develop a model that very similar to one that you can find also here. So if you don't have a possibility of downloading and installing NetLogo, you can go to the NetLogo page, and you should see here library, and so you can say start with anyone. You can run it into the web, because it can also run directly on the web. Then you can go to authoring, and you can edit and say remove elements or add other elements. And then you can go to the code tab. Let me reduce the size of this. Here you have the code tab where you can enter your code. The only problem with the web edition is that you have then to download the system on your disk, say export as HTML. I have probably to say something here. Let me see. I remove this. No. Why I can't export? Interactive. I have to save it on my local directory, say here, and then if you want to launch what you have done, you have to start from your say local directory, and you can now launch your model. Okay, so the performances are very different. I suggest you, if possible, to use the native application, but it also runs on a browser, and this is particularly important if you want to use it, say, for teaching or for demonstration, because the web version works also on tablet, on phones, and so on. So it can be useful. I shall show you at the end how to use it on the web. Okay, so the problem that I want to say illustrate is how a fire spreads on a forest. Okay, so I want to, first of all, use my squares, my patches, representing a tree. So I want to generate a forest, say, with a given density. Then I shall put fire on one of these trees, and then I choose, so we have to decide what will happen with this fire. Okay, so let's start. I want a button, say, to set up. Okay, it is red in this moment because it is not valid. There is no setup procedure. Maybe I also add the slider for the density. Mettiamo 3 density from 0 to 100, step 1, units percent. Oh, notice that almost all expressions without spaces can be used as a variable name, including question marks, dashes, or Unicode letters. The problem is that if you want to use a minus, you have to or any operator, you have to space it, to put a space before and after it. I shall show you. Okay, okay. So let's go to the code page. If I press Control, I can have this detached so that I can see both the interface and the code. Clearly, the code page has nothing. Then I have to define to setup. To setup, and so this is an empty procedure. But now he is happy. I can press setup. Clearly, it doesn't do anything. To set up, I have to ask, which is essentially the way of sending messages, patches in order to change their color. So I can test my command here. So ask, for instance, patch 00 set p-color red, for instance, and then patch number 00. Remember, the coordinates are set when I set the word. So I can define where is the origin, if in the center, corner, edge, or custom. How many coordinates are there, and so on. Okay, so patch 00 is just one patch. Okay, then I can ask another patch. So patch, I don't know, 5 3 set p-color green. Okay, or I can ask all patches. Ask patches set p-color yellow, and clearly all patches take this color. Then I can, okay, so how can I ask a fraction of patches? There are at least two ways. First of all, I can ask all patches, and this here is the procedure. What to do? If random float 1, so random float 1, then I shall show you where all these commands are defined. So random float 1 gives a random number, a floating random number from 0 to 1. So if this gives me a random number from 0 to 100. So if this is less than 3 density, I define the 3 density from 0 to 100. Okay. Yes, Sarah. Sarah asked something. Sarah Ristori? Maybe it was an error. Okay. In case, Sarah, you can open your microphone and enter. And okay. So if this happens with probability equal to 3 density divided 100, set p color green. Okay, so green. So this is a way to set a certain number of patches equal to green. But you can see that the others has still the old value, the old color. So normally in the setup, we start with the command clear all that clears all variables or drawing that are on my world and all turtles that are eventually on the world. Then clearly you can clear separately each of them. So if now I start with the clear all, first of all patches are reset to value, to color and black, which is 0. And then I ask all patches to extract a random number from 0 to 100, compare it with this 3 density. If this is less, this happens with the probability 3 density. So in this case, it's 50%. Here is 10%, and here is 92%. They take color green. Okay, questions? Clear, no? It seems. Okay, but I can do something quite different that explains how this language works. This language is inspired by an old language which is called the Lisp. I don't know if any of you have heard of this, but there are a lot of software that have Lisp behind, which is a language oriented to managing a list of things. So patches essentially is a list of okay, it does not show it here. It is a list of all patches. So it is actually not a list, it is a set. It is not ordered. A set of all patches here. So I can, instead of doing this, I can select a subset of patches with a certain property. Okay, so the idea is that when you write something like this, you take a set, you apply something. Now I shall define this. If it is true, this example of the set is kept, otherwise it is discarded. And clearly what I can ask in order to discriminate is, for instance, extract a random number and compare it with the 3 density. So essentially these are let me comment this. Okay, and essentially this has the same effect as before. What happens, and also performances are slightly different. So here I ask all patches to do something. Here I say, so above, so to the controller, take all patches. Then for each of them, do something and select them. So at the end, I am asking only to a few of them. So in order to to see the difference, let me say that all of them writes here a small message. So, and also in the other case. So let me first start with this. Okay. Okay, so if I do this with, say, a small percentage, say 5%, okay, I see that here I have a 5% of patches that takes a color green, but I have 100 messages because all patches are, say, saying hello, 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 okay? While if I do this, I have the same 10% here, but only I have to clear this because we don't see anything otherwise. Only something wrong. Fabio Ballerini have to sign you on the other. Something wrong. It is not how I imagined, but the idea is that only.
Can you repeat, please?
Okay, Fabio?
Yeah.
Yes. You have to sign your presence on the form that I put again on the chat.
Thank you so much.
Okay, so it is not working as I thought, but okay. They have the same effect. Okay, now I want to have another button here. They say go. And so with this button, so maybe at the end of setup, I choose one tree and I set a fire on it. Say, ask one of trees of patches set p color red. Okay, so now I have a lot of patches and one of them is red. Let me remove this show yellow. Okay, clearly it has some sense if if the density is sufficiently high. Okay, now with the go, the idea is that a green patch which is near to a red one becomes red. So to go, ask patches with I can do several ways. P color equal green. If any neighbors, so let me with P color equal red, set P color red. Let me explain. So first of all, let me see if it is working. Okay. So what does happens here? I'm asking to all patches which are green. It checks, yes, the language is some very natural. So equal is the test. Set are assignation are done with the set keyword. So I shall revise the language in a moment. Okay, so any of the green pages takes neighbors. Neighbors is the set of the all neighbors. Remember, everything here is done with lists and sets. Sets are like lists but are not ordered. So it takes the list or the set of 8 neighbors, selects those that have a color equal to red, and any takes this set and returns true if there is at least one member, 0 if there is no members. Okay, so if there is at least one, essentially, neighbors with the p color equal to red, this also set p color red. So essentially what happens is that at every step all connected patches with at least one neighbors equal to red are becoming red. Is it clear? Okay, so clearly these are the first steps. So first of all, let's see where I can find the information about the languages. Essentially, you can go to the help and go to the NetLogo dictionary, which is an online essentially manual with a lot of information. So you have procedures that are related to turtles, to patches. Then I shall show you that patches can be connected by links. Agent set, for instance, any, here it is a procedure that takes as argument an agent set, a set of agents, and returns true if this is not empty and false otherwise. Nobody is essentially test if this something is really an agent or it is nobody, and so on. So, for instance, with another command that we have seen, it takes essentially an agent set and something that returns true or false, a reporter. And for each agent, it applies this reporter. And if the reporter returns true, the agent is kept. If this reports false, the agent is thrown away. So essentially, if you have studied set algebras, say at high school or university, this is something that remembers the manipulation of sets and also of lists. Okay, then let me see. We have okay, so this is the assignation. What is in most of other languages is done with the equal sign. Here it is, you have to explicitly set one variable equal to another variable, to a value, excuse me. And okay, so here you have your manual that we shall say examine in detail in the following. Okay, so are there any question? No. Okay, so let us add another element here, for instance, a plot. Suppose that I want to number of burning trees, for instance. I want to plot the time evolution of my fire, for instance. So these they are very limited plots here. You can put the labels of the axis, burning trees. Okay, then you can have a certain number of pen for plotting different things. And the interesting point is that you can plot things here either from the code session or simply putting what you want to plot here. In this case, for instance, count patches with p color equal to red. Count is another operator that takes an agent set and returns the number of the members of this agent set. Okay. But there is one caveat, is that this command, if you put it here, it is executed every time that times is increased. So I have to here to reset the time, and here I have to tick, otherwise the clock which is shown here does not advance. Okay, so now if I set up ticks goes to 0, and every time, okay, this let's start with a higher density. Every time that I click, you see that it adds a click, and it adds a portion to this curve that clearly has a classical logistic curve, because the fire spreads at a certain point, it reaches say the maximum. Okay, now clearly normally one develops the model for small lattices, then one say increases the size of the lattice. Okay, so that I can appreciate more what happens. See that here I have a periodic boundary conditions. This can also be set here. So if I don't want to have periodic boundary conditions, I can have a fixed boundary conditions, maybe in one dimension, in one direction or the other. Then another point is that you have seen that normally I have to click this, so I can select the button to be a forever button, so that I don't have to continuously click on the go button, but it goes, say, not forever. Clearly, at a certain point, I have to stop. Clearly, I can also stop it when a certain condition is met in the code phase. Okay. Then we can try to change a bit this. For instance, I may want to, I don't know, to explore what happens for different densities, no? So clearly I can repeat the simulation several times and see that, for instance, about say 40%, I have a final percentage which suddenly grows, say, from almost 0 to something very large. It is a classical phase transition. If you may want to explore this in different ways. One way is to use a tool that is included in NetLogo, which is called the behavior space. And essentially, it is a way of repeating this experiment several times. So, for instance, I can ask, say, phase transition. Okay, I choose here behavior space, and so vary this variable. I don't remember how it is written to make say from 0 to 100. Let me remember, because they changed something just okay. So I have to put it in this way: from 0 to step 1 to 100. For each of these, I can have, say, maybe not 10, 5, 4, just to say. I can have, say, 3 repetition for each of these value. What I want to measure, I want to measure count patches with p color equal to red. I can measure this every time or only at the end. The setup command is set up, then go, and stop condition maybe time limit, for instance, after 400. Clearly, I can set up something to be to be stopped when this number does not change. There are several conditions that I can do. Okay, and if I set up all of this, run, then it produces a spreadsheet. And with the results of my experiment. It is running a lot of different experiments. It uses several cores. If you have more cores, it uses all the cores available. Here I have, you can see it is a fully used all cores of my Macintosh. I have 10 cores and they are used. Not these two because they are low-level cores, but the others are used. And at the end, it produces a spreadsheet with your simulation. So it is interesting that you can perform a kind of automated experiment without having to program from scratch. Okay? But you can also do something different. For instance, in this case, I could do something like this. So I may make my word much wider than higher. For instance, let me put 300 by 100. Now, instead of using just a single density, I can set up a gradient of density, say from some minimum value to some large value. So, for instance, this can be called the mean tree density. Okay, and then I add another slider here, which I call max tree density. Okay, now I want that the probability with which I set up my trees, so instead of this, I revert to the other formulation. So now I ask patches, but instead of having just a fixed tree density, I make a tree density that changes continuously from the minimum to the maximum in a linear way. So maybe I define a variable. With let, I define a local variable. So the local variable, maybe it is better if I start my min 0, let me say custom, minus, I don't know why, oh, maybe also in the corner, it's okay, here. Okay, so now I have my span in X that goes from 0 to 300, and in Y I don't care. So, okay, so maybe also to 600. Okay, now each patch has a variable which is called the px core, which is clearly the x coordinate. Then I shall explain why the p. But remember that patches, the coordinates of patches are p x core and p y core. Okay, so x core goes from 0 to the maximum, which is called the max px core. So px core divided, remember that you have to put the spaces because for NetLogo this is a valid variable number, which is interesting because you can make a very expressive variable number, but it has the disadvantage that you have to put spaces. So this is something that goes from 0 to 1. No? 0 here and 1 here. So I want to instead this variable go from minimum to maximum. So I multiply this with the max tree density minus min tree density. So now it goes from 0 to this difference. So I add min tree density. Now, when this is 0, this all, when this is 0, this all is 0. So it goes to, here is a minimum tree density, here. Now remember that the minimum peak score is 0 and maximum is some value, 600. When this is equal to max, this is 1, so min tree density goes away, and I have the maximum. And this is a local density. So now, for instance, if I put here 0 and here 100, I should have maybe we can go faster. I have still the hello here, which slows things. Okay, set up. Okay, much better. Okay, now I have a gradient from 0 to 100. Clearly, if this starts from 50%, now I have a gradient from 50% to 100. And now the idea is that I set fire on this line and measure how much it goes into my forest. So ask patches with px core equal to max px core. So now, okay, set up. Now this is my setup. Okay, and then I have my fire that goes up to a certain position. Now, for instance, I can let me just save this example so that I can save as forest fire gradient. The other I haven't not saved, but I can recover easily. Okay. And now, for instance, let me change a bit the display. So, for instance, I want to put, let me put them there. I want to put a plot here. Say a plot from here to here. Maybe with the button. So here I don't want any command since I'm plotting using the command here. So to do plot. Now what I can do, I can say I'm performing a scan from 0, from minus, from px core equal to 0 to maximum px core, and to plot the number of trees which have burned corresponding to these coordinates. This can be done again in several ways. So the way that may resemble, say, C, Java, MATLAB, and so on, is to do a loop, which is not the spirit of NetLogo. But first, let's start with the loop to show that you can also use the standard way of programming. So, for instance, let E0 while E less or equal max px core let me define a variable, let x0, because with let I define and assign a value to a local variable. Then I use a set to change their variable. Quindi set x count patches with px core equal to y and p color equal to red. So for each value of I count the patches that have these px core, these coordinates, and color equal to red, maybe divided world height, which is how many patches are on a line, and then plot plot xy ex, set e plus 1. And let me see if maybe we have to set the maximum of x to 1. The y I can set it, but it adjusts. So, and so if I do plot, okay, yes, in order to have the same scale, I have also to convert the I. So let me call this y instead. Let x 0, and so this is y, while the x is equal to this one. Set x I, and then now x y. In order to have a, I'm converting the scale to this value. Just to have the same nothing name, and let x, okay. Let me see, go. Okay, and I have to again to reset the x max to 1, and y max to 1, no x max to 1. Okay. So now clearly I can put the values, okay, but so I can say have plot x, yes. Now I can see that you see that when I move the cursor, I have the values. So I can see, okay, my transition is about 36%. Now I can refine, say, from 32 to 42, go. Okay, now, okay, it is essentially the transition should be like this. World height. Okay, this goes, I don't know why it is going to not 1. Set count patches with this divided by world height. And 201. This should be between 0 and 1, but I don't see here 1. But something wrong. I have to check this. Okay. This is because it has not adjusted this. So let's adjust before the plot. Set mean plot range. No, set plot range. Set plot range. The problem with NetLogo is that it is easy to forget the commands, so I have to go to the NetLogo plotting, set plot x max, plot x min. Here is so set plot x min, set plot x min this min 3 density, set plot x max 3 density. Now this is just for reading the maximum and minimum, and for setting, let me see, set plot x range. I remember well. Set plot x range. Okay, set set plot x range. Probably it is set plot x range max min max. Let's see if now it is okay. So set up, go, do plot. Okay, now it corresponds to the same position like this, no? So, okay, clearly here goes to 1 at the end. So if I increase the range, go, do plots. Okay, now it corresponds exactly to the same position. Okay, so maybe I can save this one. Okay, so this is so how we can use these things. So let's try to put to work with say with the turtles now. So for instance, we can set up for instance, for the moment we can just set up a model in which you have one say one turtle that performs say a random motion. Please just please show the code. Yes. If you have to tell me something, don't hesitate. So Ali Pashazadeh says, I use codes, but it does not apply. Apply, you mean to show in the model, or it doesn't work? I can also increase. Oh, it is okay now. Okay. So please, if you have to say something, you can switch your microphone on, because I don't always look at the chat. So clearly, if you want also, I can also set up a shared Google Drive if you want to pick. I shall publish clearly all this code, but if you want to see them, say, live, I can also work on a shared Google Drive if you want. Let me set up this so that you can see directly what is going on. So let me change my ID. Say new folder. Folder is say NetLogo 2024. Create. Okay, then I share with anybody. Okay, and then I can put, I can work on this essentially. So let me Save as Unifi, my drive, NetLogo. Is it synchronized? Here it is. Okay. Okay, so you should be able to access my drive on Google Drive, look for NetLogo 2024, and have this example there if you want. And then I shall link it on the web page. Okay, so let's start from a new one. So you can try to suggest me what I should do in order to have, say, create something here that moves randomly on my screen. So first of all, please try to suggest on the chat or say using a microphone. The first step is always a button called setup. Thank you. Okay. And then there is another button called
Go.
Go, which is a forever button. Okay. So a slider, yes, could be a slider, say for variation. We can put it together after. We can see, for instance, how a turtle can say steer, how much it can steer. Let's say, well, let's put a slider. Say variation. Then we specify better what this means. Okay. So now let's go to turtles. Turtles, first of all, turtles can have several shapes. Here there are a few. Then there is also a library with a lot of shapes. And you can also draw your own shape. For the moment, we can, for instance, use the bug shape. Okay, so to set up and to go and. So first of all, we start with the clear all. Clear all can be, say, shortened to CA. And then generally it ends with the reset ticks, and go also normally ends with the tick. Okay. Well, here I can do something, but for the moment, okay, create turtles. This is a command that creates a certain number of turtles. 1. Then I can give this newly born turtle the command that it executes at the beginning. So set shape bug, and for the moment I don't need anything. To go, I ask all turtles to do something. So a turtle like this one has a certain number of variables that we can examine now. So who, I say, is the ID of this turtle? The ID of the patch is the coordinates, while the ID of a turtle is its who number. Starts from 0. If I create another turtle, it takes value 1 and so on. It has a color. It has a heading. A heading is the direction on which it is oriented. Notice that in NetLogo, 0 is the north. They use 360 degrees and use clockwise orientation. So it seems essentially completely different from on the normal convention. So, for instance, if I ask to have a heading 90, it goes like this. Minus 90, it goes like this. So north is 0, which is in some sense is more natural than having 0 on the right. So north is 0 and goes clockwise for you. Okay. Then another interesting thing is that it has a pen that can be up or down. If it is down, it leaves a track, and we shall use this for, say, something. Clearly, you can define the size of the pen, the size of the bug. This is a big bug, and this is a little one. This is an even smaller one. It can be hidden or shown. And we shall see what breed means, color, label, and so on. Okay, so we can ask turtles to go forward in the direction for some number of some distance. One is, so the distance is measured in terms of patches. So 1 means go forward for 1 patch, and clearly it depends on how small are the patches. And then set heading. You can ask them to turn right for a certain number of degrees, turn left for a certain number of degrees, or manipulate the heading. So suppose that we variate the heading.
There's a type in the code in forward.
Yes, forward.
An extra D in the middle.
Yes. But it will show here, so thanks, but you cannot go on with an error. So
sorry, did not.
Thanks. So I mean, we can ask the heading to change of this amount, for instance, in plus or minus. So say 2 times random float 1 minus 1. So essentially, this gives me a number from 0 to 1. This gives a random from 0 to 1. I can put this, but it is not necessary. It is not mandatory. Yeah? Okay. So this gives me a number from minus 1 to 1, and this gives me a number from minus variation to plus variation. And I think it is enough. Let me check. Okay. Setup. Let me save it. Save as, say, random walk. Laura Recchi, esercizio 1, PDF, something. I have saved here something wrong. Let me save as. I have used the wrong application, random walk. Let me just wait a minute. I opened the old model before. This is not useful. I had it, I think, on here. No. It was gradient something. I have saved it locally, so somewhere should be. Here it is. So I can put this on NetLogo here. And this can be removed. Okay, so you have the right things there. Okay, so setup. You see that every time that I create a turtle, it has a random orientation and a random color. And so let me go to slow speed, and now it starts wandering on my screen. So maybe I can ask them to put pen down so that I can appreciate the random walk. Clearly, if I increase the variation, it should variate more the path. Something which is not working very well. Now I have to investigate. So with
I think the issue is because heading should
yeah,
exactly.
Exactly, yes. So now we should, so 0 is not working, but okay, now better. And for instance, now I could be interested in not setting just one turtle, but a lot of turtles. Maybe too many, okay. It is slow. Maybe instead of, let's put some larger number of patches, which is not really, I can just reduce the forward step. And say forward 0.01. Okay. So maybe we can go a bit faster, or we can create, say less, say 20, 30. Okay, so if you need, you can appreciate that maybe we can go a bit farther. Okay. And so you can appreciate that it should be more or less, say, spherical, but after a certain point, it starts to develop, and for showing, we have to reduce the number of steps that start showing certain number of protuberances. Okay. Any question for this? Okay, so now I propose you to explore another model, which is also in the library, which is called the diffusion limited aggregation, in which now I am creating the same random walkers, but say near the border. Then I put a single patch in the middle. And so the idea is to model what happens in dendritic growth of material, in which you have some, so generally some salt, some ionic metal, so some salt dissolved in water, and if these metal particles meet another metal particle, they stick there, and so the dendrite slowly grows. So the idea is to create, say, random walkers near the border. Then have them perform a random walker on the walks. If they come near to another stick particle, they stick there. So, or better, they turn the color of the patch into, say, white and die. So, okay, so the idea is that now I don't need this one. In the setup, I clear all. Now maybe a slider can be useful. Say number walkers. So I can decide how many walkers are there. Allora, to set up, create turtles, turtles, number walkers, and set shape circle, set color, I don't know, yellow. And then I want to place them near a border. So actually I can just set, since we use a periodic boundary condition, I can just set them, say, near the 0. If I put the 0 here, I just put them either here or here. Since when they diffuse, they can go in this direction or the other direction. So set, so mettiamo if random random gives a random integer from 0 to this -1. So if else, say, quindi with the 50% I say set x, y, 0 random float world height, and the other 50% set x, y world width, no, random float 0. Okay, so random float, remember, gives a random number from 0 to this one. So now I'm putting them to either to x0 x coordinate and say uniformly diffused here, or 0 y coordinates and uniformly diffused here. Let's check if it works. Create the turtles. This I comment, and then we shall work on this. So setup, okay, they are essentially here and here. Then I ask the central patch, ask patch. So actually it is much better to use 0 in the middle, because it is if I want to perform measurements. So these are not 0, but it is mine p x core, and this is mine py core. Okay. There should not be needed, but ask patch 0. This is the set p color white. This is my seed. So setup. Now I have maybe this has to be made smaller. Okay. So I have some turtle here and some turtle here. Now, ask patches, this is okay. Set heading plus 2 times, I don't know, 180, like before. So now I have reset the ticks. Okay. So now I have just the things that are wandering in the system. Maybe we can increase the forward steps, and otherwise we have to wait a lot. So now we have simply things that are wandering. But now, if any neighbors, so what is interesting is that the neighbors is that the turtles can access the variables of the patches below them. So neighbors actually is a command for the patches, not for the turtle. But patches can use variables of turtles, and this is the reason why turtles coordinates are px core and py core, because patches coordinates are px core and py core, because turtle coordinates are x core and y core. So if a turtle says set x core or show x core, now it plots its own coordinates. But if I ask them to show px core, it shows the coordinates of the patches below them. And also for color, p color is the color of the patch below them, and color is the color of the turtles. So if any neighbors with p color equal white, quindi if it means if the patch below me has any neighbor which is white, I set the color of the patch below me equal to white, and then I move again to this random position. So it is better to convert this to a procedure, say to reposition. If you press tab, it reformats this. So here I can reposition, and here also reposition. So it is recycled for another run. It is like those who stick here are replaced by a random one. Clearly, I could also make this turtle to die and create another one. It is essentially the same. Okay, let me check. Set the color, not with the equal. Check. Okay. So let's see if this works. Set up something, reposition. No, I put this in the wrong position. It is the turtle which has to reposition, not the patch. Okay. And now maybe let's start with a smaller number of patches so that we can see better what is going on. So, okay, now we have to monitor the growth of these things. So let me use more patches. Okay. And so this is another quite well-known example of an interesting phenomena, which is so diffusion limited aggregation. In principle, this should be a fractal. Actually, it is a fractal only if I use just one walk at any time. Otherwise, it may happen that more than one walker sticks to the same position. So, but if I use a small enough number of walkers, this should be essentially a fractal. Questions?
Yes, the reposition is so that you have the same amount of particles at any time?
Exactly. Clearly, you could instead say, okay, now here I die, and before I create another turtle and I die. This is a possibility. Otherwise, I could monitor the number of turtles and recreate them if they are if it is too small. Or you can start simply with a certain number of patches and then you don't reposition. In this case, you have a different growth at different times. So it depends on what you are exploring.
Okay, thank you.
And now, for instance, just for finishing, we could say plot the size of this. Say, for instance, the gyration radius of this figure, just to see how it grows, for instance. So let's suppose we add the plot. Gyration radius. We have to compute the gyration radius. And so the gyration radius is simply I add I make the sum of x square and the sum of y square, and I interpreted them as a radius, and this is essentially the equivalence of the momentum of inertia of this figure if it were some made, say, with clay or with some other material. This is just for introducing global variables. So globals, say sum x2 and sum y2, which is clearly the sum of x square and the sum of y square. They are automatically initialized to 0. So here I have just to say set sum x2 plus px core squared. I think I have also to put the the number of contribution that I added. So set sum y square plus py core, set n plus 1. And now I can, okay, I can also say compute the gyration radio. R, say set R s square root of sum x square divided by n, no, yes, divided by n plus sum y square divided by n. Should be something like this, no? So this is the x square mean, and this is the mean y square. And now here I can plot R. Okay. With plot, it means that the x is an increasing number, and this is only the y value. And I have to tick here. Okay, it is already here. Let me see if it works. Okay, here I have how the mean square root grows with time, and one can check if this growth is what maybe Michele Giusfredi, who is working on this kind of things, may check if this growth what is expected. Clearly, it is the right one only if I have just one random walk per time, but this is the idea. You see that it is not trivial what happens, and so on. Okay, so I ask you if you have questions, if you have already suggestions for say next lesson. Clearly, I would like to now develop some model in which I don't know, we can have models from biology where you have say epidemics or people, or say cow that eats grass and are eaten by wolves, or I don't know, starship that combats in the space. Let me, so I ask all of you to try to formulate a simple models, send me some suggestions, and we can try to implement them next time. So let me save this as DLA. So I can show you just a few examples, for instance, ones that I have developed for teaching physics. Let me see. One, for instance, is this one. This is very simple. You can define the initial velocity and the inclination of your cannon, and then you can try to check how is the range which you can reach by changing the initial angle, and verify that with a given initial velocity the maximum span is for 45 degree. Then we can, for instance, add friction and see if this changes with friction. And for instance, this can be used in a more practical situation where you have now to aim your cannon to a ship, but the ship goes is traveling, so it is not so easy to get it shot. But when you can shot them, shot it, it syncs, and then should give you the parameters that have been successful for shooting, and then you can check this, say, with handmade calculation, assuming that the ship is traveling at constant speed, starting from a certain distance, and so on. And so this is an example. Clearly, we can just for suggesting you what we can do with NetLogo. Another one that I used let me see. For instance, you could we could explore the Mandelbrot set, which is an interesting example. This is the initial x and y coordinates. You have a certain iteration of variables that defines for each of these initial conditions. Maybe I can illustrate it better using a chaotic pendulum. Then I can back to Mandelbrot. This, for instance. So this is made for a cellular phone. Okay, in this model, you have a pendulum. This is the pendulum seen from above, which has a piece of iron at the end. You have 3 magnets with different colors, and then you want to find the attractors of these 3 magnets. So if you start near to one magnet, see clearly it goes to this magnet. So they are marked red because they belong to the same attractor. No? But sometimes you see that it is not so trivial to go to the right attractor, and actually the attractor is a fractal. So this is the attractor at a given resolution, but it is much more refined than this. And so, for instance, you can explore these concepts using NetLogo. And Mandelbrot set is something similar. So you have, these are the starting points, and if they go to infinity, they are colored in some way according to the speed that they go to infinity. If they stay, they are colored black. And what is interesting is that you can say zoom on a portion and appreciate that indeed it is a fractal which has always the same features, going in details and so on. And if you set a point, this is the map. So you see that here the map stays near, but if you go near the border, the map goes to infinity. So clearly you may maybe magnify a portion and appreciate that near here it stays confined, while just here it goes to infinity. And so yeah, I use a lot NetLogo for say investigating this, also for testing ideas before going to the real hard simulation. But I would like to hear from you ideas, suggestions, and also so invite you to try something clearly. Maybe you can wait for the next lessons, but I think that it is extremely more proficient if you participate into this course by, say, trying and suggesting. Okay? So, are there any questions, comments?
I want to just thank you for this lesson. And I think the folder, the share folder, is not visible for me, at least. I don't know about the other people for the files.
You mean that it is what are you studying for beginning?
Smart computing.
Smart computing. And you see that it is not useful for, say, for smart computing, probably not. It is essentially a didactic tool. So you can use it for, say, teaching neural networks or...
Yes, it's useful. Maybe I can use it for the waves in actually 5G networks or other stuff like that.
Okay, so if you have suggestions, things that we can test or try to implement, please send me some line.
No, but well, at least for now. But if I have an idea, I will write you by email.
Okay. And others, essentially people, for instance, that who do not come from hard sciences, I'm interested because I would like also to develop models for, I don't know, psychology or social science or even humanities. So if any of you have some idea, it could be interesting. Okay, if no one wants to say opinion, I say you goodbye and see you next Tuesday.
Thank you.
Grazie,
Thank you.
arrivederci.
Thank you.
Grazie, grazie.
Thank you.
Thank you.